If you need extra practice in writing quadratic equations, here's 4 examples. This first one says the table represents a quadratic function. Write an equation of the function in vertex form. Looking at the table, I see x goes -3, -2, 1, and 0, and the f of x row goes 8, 5, 4, 5. And using characteristics of the parabola, the shape of the parabola, we do have symmetry to the left and to the right of the vertex. So if I see the y value 5 here and 5 here, both on the left and on the right, then this must be the vertex, -1, 4. So we like to call the vertex h and k. So h is the x-coordinate, h is -1, and k is the y-coordinate, or the f of x value. K is 4. So we have a vertex -1, 4. And if we're given the vertex, then the equation we want to write should be in vertex form. So let's go ahead and write vertex form. We have y equals, or f of x equals, a times x minus h squared plus k. So we can make our substitution with h and k. Y equals a times x minus -1 will turn into x plus 1 squared plus 4. Now we have to find the value of a, the leading coefficient. So what we could do is we can pick an x and a y from our table, and we could plug that in to solve for a. So how about this one, 0 and 5? So we can let x be 0 and y be 5. So plug those two values in. Now we have 5 equals a times 0 plus 1 squared plus 4. Now we have one equation and one variable, so we can solve for a. Let's go ahead and do 0 plus 1 first. So that's a times 1 squared plus 4. Following the order of operations, we want to simplify 1 squared first. 1 squared is just 1. So that leaves us with a plus 4. To solve for a, subtract 4 from both sides. We get a equals 1. So that's the leading coefficient. Let's go back to our vertex form right here. And we're going to plug in 1 for a. Now we have our equation. Y equals 1 times, or just, x plus 1 squared plus 4. This next example says write a quadratic function in intercept form whose graph is shown. Here I know one point is -4, 0, another point 6, -5, and a third point 8, 0. And something special about this graph is we are given the x-intercepts of the parabola, and because we're given the intercepts, we can write the equation in intercept form. That'll be y equals a times x minus p times x minus q, where p and q are the x-intercepts. So let's take the value of p. P is -4, and q is +8. Let's do that substitution. Y equals a times x minus -4 turns into x plus 4 times x minus 8. Now we have to figure out this leading coefficient a. In order to do that, we can take a point on our parabola, like 6, -5, and plug in those values for x and y to solve for a. So now we can let x be 6 and y be -5. Substitute. -5 equals a times 6 plus 4 times 6 minus 8. Now we have one equation and one variable a. We can solve for a. On the left, -5 equals, on the right, a times 6 and 4 make 10 times 6 minus 8, that's -2. Simplify the right-hand side, -5 equals, that's -20 times a. And we write the -20 first and then the a. Then to solve for a, divide both sides by -20. We get a equals +1/4, because 5 over 20 simplifies to 1/4. So now we can take our equation here, and we can write a as 1/4. Y equals 1/4 times x plus 4 times x minus 8. This next example describes a real-life situation where we can write a quadratic equation to model the path of a projectile. It says a performer is shot out of a cannon from a height of 20 feet. The performer reaches a maximum height of 30 feet after traveling 25 feet horizontally and then lands in a net 60 feet from the cannon. The path of the performer can be modeled by a parabola where y is the height in feet and x is the horizontal distance traveled in feet. What is the height of the net? Part of the solution is to sketch a graph of what the problem is describing. So if the performer is shot from a cannon from a height of 20 feet, that'll be this initial point right here, because the horizontal distance from the cannon is 0 and the height of the cannon is 20. The performer reaches a maximum height of 30 feet after traveling 25 feet horizontally. So that word maximum is describing the vertex. It's going to describe the highest point compared to all the nearby points. So that has the coordinates 25, 30. And then lands in a net 60 feet from the cannon. So that is the horizontal distance 60. And then the height of the net is something that we don't know. So we can call that question mark. So that ordered pair, we know x is 60, but we don't know y. So in order to figure out that y coordinate, we can write an equation of this parabola and then evaluate when x equals 60. So step 1 is to write the equation. Notice we're given the vertex here, h, comma, k, where h is 25 and k is 30. So we're going to write our equation in vertex form. So vertex form is y equals a times x minus h squared plus k, where h is 25 and k is 30. So let's put 25 in for h and 30 in for k. So we get y equals a times x minus 25 squared plus 30. Then to write the equation, we need to figure out what a is. So we can choose a point on the graph, like 0, 20, and we can say sum x, y, where x is 0 and y is 20. And we can plug those values in to solve for a. So now we have 20 and 0. And h is 25. And k is 30. So now we have one equation and only one variable, so we could solve for that variable a. On the left is 20. On the right, we can do 0 minus 25 first. So that gives us negative 25 squared plus 30. And then square the negative 25. If you don't have your 25 times tables memorized, you can use a calculator. So remember, negative 25 goes in parentheses to the power of 2. So that gives us positive 625. 20 equals positive 625 times a plus 30. Then to solve for a, we can subtract 30 from both sides to get negative 10 equals 625a. And then divide both sides by 625. We get a equals negative 0.016. Good. So we're going to take this value for a and put that into our equation here. So now our equation becomes y equals negative 0.016 times x minus 25 squared plus 30. Now to figure out this final part of the question, if we want to find the height of the net, that is 60 feet horizontally from the cannon, we could just plug in x equals 60 and then solve for y. So now our y equals negative 0.016 times, and now plug in 60 minus 25 squared plus 30, negative 0.016. And if you're using a TI-83, you can also do second ands, so that'll pull up the answer, and then parentheses 60 minus 25 to the power of 2 plus 30. And that gives us that y coordinate, that height of the net, equals 10.4 feet. And example 4. A meteorologist creates a parabola to predict the temperature tomorrow, where x is the number of hours after midnight and y is the temperature in degrees Celsius. Write a function f that models the temperature over time. What is the coldest temperature? Part of the solution here is to graph the points that we know. So we know if x-axis is the hours after midnight and the y-axis is temperature in degrees Celsius, that means at midnight, at 0 hours after midnight, that's midnight, we have 0, 6.3. So that means 6.3 degrees Celsius at midnight. Then moving along the graph, 6 hours after midnight, so now that is 6 a.m. 6 a.m. we have 0 degrees Celsius. And then the temperature dips below 0 degrees Celsius and then comes back up, crosses the x-axis again, 21 hours after midnight. So that is at 9 p.m. So at 9 p.m., again, 0 degrees Celsius. So we can write the equation of this parabola given these 3 points. And something special about these points right here is that these are x-intercepts. So x-intercepts P and Q. P is 6 and Q is 21. So we're going to plug in P and Q into our intercept form. Remember intercept form, y equals a times x minus p times x minus q. So let's substitute 6 and 21. Y equals a times x minus 6 times x minus 21. Now to find the value of a, so we can write our equation, we need to take a point that is on the graph. So this point is labeled 0, 6.3. So 0 is the x and 6.3 is the y. So let's make those substitutions where x is 0 and y is 6.3. Now we have 6.3 equals a times 0 minus 6 times 0 minus 21. And now we have one equation and one variable, so we can solve for a. On the left is 6.3 equals, on the right we have a times, that's negative 6 times negative 21. We can simplify negative 6 times negative 21, and that is positive 126. So that's 6.3 equals 126 times a. To solve for a, divide both sides by 126. We get a equals 0.05. So let's take the value of a and plug it into our intercept form here. So that's y equals 0.05 times x minus 6 times x minus 21. And now that we know the equation of the parabola, we can figure out what the question is asking. The question is asking what is the coldest temperature? And that is going to describe this point right here. And the coordinates of the vertex is something that we have to calculate. So for the vertex, not only do we not know the x-coordinate, but we don't know the y-coordinate either. And there is a formula to figure out the x-coordinate. That is p plus q divided by 2. So we're going to take 6 and 21 and then divide by 2. So we get an x-coordinate of 27 divided by 2. 27 divided by 2 we can write as a decimal. That is 13.5. So we know the x-coordinate, 13.5 hours after midnight, so that is 1:30 p.m. And now to figure out the y-coordinate, we plug in the x-coordinate into our equation here. So now y equals 0.05 times 13.5 minus 6 times 13.5 minus 21. And this is something you could type directly into your calculator. 0.05 times 13.5 minus 6 times 13.5 minus 21. And we get that minimum, that lowest temperature, to be negative 2.8125, or about negative 2.8 degrees Celsius.